Hi, welcome back to Moose in Chemistry. This is SI units, direct and inverse proportion. So what are direct and inverse proportions? Well, let's look at their definitions first. Direct proportions is where one variable increases and the other variable increases. Okay, so if one increases, the other one's going to increase. Inverse proportion is where one variable increases and the other variable decreases. So let's look at examples of direct and inverse proportions. Here's the first one. The faster you go, the less time it takes to cover the distance. Well, think about this. If you're on a trip and you're going to go 100 miles and you're going at, say, 60 miles an hour, it's going to take you less time to get there to that destination than if you're going 30 miles an hour going the same distance. See? So the faster you go, the less time it takes. That is an inverse proportion. The second one, the greater the pressure, the less the volume of gas you have. Think about this. If you're going scuba diving, and you'll have to remember that every 33 feet of water represents 1 atmosphere of pressure. So you have to also add that to 1 atmosphere of air above it. So at 33 feet, you're actually at 2 atmospheres of pressure. So if you were to take a balloon down to 33 feet, the volume of that balloon would decrease as the pressure around that balloon increases. In the same relationship, you can look at this in another way. If you were to exhale air at 33 feet, let's say the air bubble was the size of a quarter, by the time that air bubble got to the surface, it's about the size of a volleyball. So as you decrease the pressure, you increase the volume. Again, that's another example of inverse proportion. All right? The more lemonade you sell, the more money you will make. That's a direct proportion. The more magnesium you dissolve in hydrochloric acid, the more magnesium chloride and hydrogen you will produce. That is also a direct proportion. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moose in Chemistry!